In the 17th century, René Descartes, a French mathematician, created the geometry of Cartesian coordinates. As such, he is considered the father of coordinate geometry. Coordinate geometry combines geometric principles while using numerical coordinates and equations on a plane to explain and analyze geometric figures and shapes. Real-life applications of coordinate geometry include career disciplines in engineering and architecture, navigation and geographic information systems, physics and kinematics, animation and computer graphics, and robotics and automation. In this project, I will demonstrate how coordinate geometry can be utilized in the navigation and geographic information systems, specifically in GPS tracking, where one can find exact locations on the Earth's surface by utilizing latitudes and longitudes as a base. For the purposes of this project, I'll be utilizing the distance in a 2D coordinate plane. The first step is to pick 2 points that are in the same country for accurate results. I picked Knott's Berry Farm in California and Disney World in Florida. To find the air distance, you must first find the longitude and latitude of each place. Through Google search, the longitude coordinate of Knott's is 118.0002 degrees west, and the latitude coordinate is 33.8443 degrees north. For Disney World, the longitude coordinate is 81.5707 degrees west, and the latitude coordinate is 28.3772 degrees north. Next, you convert longitude and latitude to miles. 1 degree longitude equals approximately 54.6 miles, and 1 degree latitude equals approximately 69 miles. For Knott's, we'll be multiplying the longitude by 54.6 miles, which will give us 6,442.8109 miles. This number will represent x1. For the latitude, we'll be multiplying by 69, which will give us 2,335.2567 miles. This number will represent y1. For Disney World, we will be multiplying the longitude by 54.6 miles, which will give us 4,453.7602 miles. This number will represent x2. For the latitude, we will be multiplying by 69, which will give us 1,958.0268 miles. This number will represent y2. With these numbers in mind, we can plug them into the distance formula. The formula is d equals square root of x2 minus x1 squared plus y2 minus y1 squared. And here's what it looks like when I plug in the numbers. The next step is to solve the equation. The final answer is 2,024.51 miles when rounded to the 100th place. According to Google Maps, the distance is approximately 2,500 miles, which isn't too far off from my answer, but this is the driving distance. If one is flying in a plane, the distance is 2,176.60 miles direct. It is important to note that in determining the distance between 2 points by utilizing the distance formula, we are looking at a distance in 2 dimensions. Since this is not realistic, we can get a more accurate distance in miles between 2 points by utilizing a 3-dimensional formula known as the Haversine formula. The Haversine formula is more accurate as it takes into account the longitude and latitude coordinates between 2 points on a sphere, which is the shape of the Earth. But as we can see, the Haversine formula is a bit more complicated than your standard distance formula. Thank you.